We present HeadCraft, modeling high-detail shape variations for animated 3D morphable models. Parametric morphable models allow for the explicit control of the shape and expression of 3D human heads. However, the variability of the modeled geometry is limited due to the difficulties of their construction. This disadvantage can be satisfied by deforming the model surface via learning the displacements of its vertices. In this work, we learn to model shape displacement variations based on a collection of 3D head scans. After registering each of them within the common surface space of a parametric model, our model learns to generate previously unseen geometry variations. In more detail, in order to register the parametric template with a 3D scan, we first fit the flame morphable model to the face landmarks of the template and subdivide it. Later, we regress vector displacements for the subdivided template vertices to roughly approximate the ground truth geometry. The learned displacements are refined along the normals to represent fine details. Subsequently, the deformation is represented in the predefined UV space with separate hair and face regions. To accurately fit the distribution of the constructed UV maps, we use a StyleGAN-based generative model that transforms a latent Z code into a novel, previously unseen UV displacement map. The map can be applied to an arbitrary template by querying the respective UVs of the template vertices and offsetting them. We compare the results of unconditional generation to the state-of-the-art method for constructing animatable head models, NPHM and ROM. Despite that both of them are capable of modeling large geometry deformations, the diversity and level of detail are generally inferior to our method. This can be further assessed by traversing the latent space of the generative models. Animation of the model is powered by rigging the parametric model. We apply displacements to the neutral shape and rotate them over time according to the deformation of the underlying template. Optimizing the latent representation of HeadCraft allows us to fit to complete 3D scans, or even match to point clouds representing only a part of the object. Due to the strong prior of HeadCraft, we are capable of reconstructing plausible geometry with large shape variations even from a very sparse point cloud. Smooth interpolation of the scans can be achieved by fitting the latent representations to the scans and blending the latents linearly. We can observe the gradual change of the head silhouette and the disappearance of tiny details. Finally, fitting the HeadCraft latents to the scans allows for transferring the geometry variation from one scan to another. Here we demonstrate the semantic editing of a source person's template by applying the model-guided displacements from different driving people, unseen during training. Thank you for your attention.